MIT researchers have found that an alloy material called the indium gallium arsenide could be suitable for high performance computer transistors. If operated at high frequencies, indium gallium arsenide transistors could one day rival silicon. For decades, silicon has so dominated the production of computer chips and transistors, but silicon's reign may not last forever. MIT researchers have found that an alloy called indium gallium arsenide could hold the potential for smaller and more energy efficient transistors. Previously, researchers thought that the performance of indium gallium arsenide transistors deteriorated at small scales, but the new study shows this apparent deterioration is not an intrinsic property of the material itself. The finding could one day help push computing power and efficiency beyond what is possible with silicon. The researchers hope this result will encourage the community to continue exploring the use of indium gallium arsenide as a channel material for transistors. Transistors are the building blocks of a computer. Their role as switches, either halting electric current or letting it flow, gives rise to a staggering array of computations, from simulating the global climate to playing cat videos on YouTube. A single laptop could contain billions of transistors. For computing power to improve in the future, as it has for decades, electrical engineers will have to develop smaller, more tightly packed transistors. To date, silicon has been the semiconducting material of choice for transistors. But indium gallium arsenide has shown hints of becoming a potential competitor. Electrons can sift through indium gallium arsenide with ease, even at low voltage. The material is known to have great electron transport properties. Indium gallium arsenide transistors can process signals quickly, potentially resulting in speedier calculations. Plus, indium gallium arsenide transistors can operate at relatively low voltage, meaning they could enhance a computer's energy efficiency. So, indium gallium arsenide might seem like a promising material for computer transistors. But there is a catch. Indium gallium arsenide's favorable electron transport properties seem to deteriorate at small scales, the scales needed to build faster and denser computer processors. The problem has led some researchers to conclude that nanoscale indium gallium arsenide transistors simply aren't suited for the task. But the MIT researchers have found that that is a misconception. The team discovered that indium gallium arsenide's small scale performance issues are due in part to oxide trapping. This phenomenon causes electrons to get stuck while trying to flow through a transistor. The research team pinpointed oxide trapping as the culprit by studying the transistor's frequency dependence, the rate at which electric pulses are sent through the transistor. At low frequencies, the performance of nanoscale indium gallium arsenide transistors appeared degraded. But at frequencies of 1 GHz or greater, they worked just fine. Oxide trapping was no longer a hindrance. When the researchers operate these devices at really high frequency, they notice that the performance is really good. They are competitive with silicon technology. The work shows that the problem to solve is not really the indium gallium arsenide transistor itself, it is this oxide trapping issue. The researchers believe this is a problem that can be solved or engineered out of, and indium gallium arsenide has shown promise in both classical and quantum computing applications.